So, welcome all in Safe Kotlin. At this point, you might be wondering, what does that mean? So it's likely that you are familiar with terms like type safety. That means extent to which program language helps you in preventing type errors. You might be familiar with memory safety. That is something nearly standard in modern languages, that the language saves you from memory management problems. Or even null safety that was introduced to a wider scale in Kotlin with a set of mechanisms that prevent nullability mistakes. So concerning all that, you might have some picture that safety is something that save you or protect you from basically yourself or your coworkers. So it is a set of mechanisms that prevents our own mistakes. So in this manner, safety is a very different word than security. So safety is a protection against danger from inside a system, so from bugs, from mistakes, when security is a protection of a system against outside threats that are viruses, hackers, etc., etc. So let's talk about Effective Kotlin, which is basically based on my book, Effective Kotlin, more concretely on the first chapter, safety. In a way, it is the most important chapter because on the end, what is the most essential for us is that our programs work properly, and it of course is important for our programs to be well designed and to scale well and to have good performance. But well, the correctness of our program is the first important step. I'm not sure how long is it going to take. We are going to describe all those items. I assume between 40 minutes an hour, so it's not a short presentation, but we have lots of important and I hope very useful knowledge that you can learn from it. So let's start with mutability. So mutability is when you can change something in a code, change a state in your program. Mutability seems to be something absolutely obvious for us all, but actually a classic book, Structuring Implementation of Computer Programs, I believe covered more than 100 pages about great features and ways how programs can be designed without even mentioning the possibility of mutate any part of the state. Some functional programming languages do not support mutability at all, or hide them from behind some special points of mutation. In Kotlin, mutability can be done everywhere, but thanks to Kotlin mechanisms, we have a lot of control over it. So mutability is when we use a var, so now we have a property that can be changed, or when we use an object that is mutable, so its internal state can be changed. So mutability is important because it is very hard to design programs without it. Although in many ways we treat mutability as something problematic, and the general rule is that we try to limit it to the necessary minimum. Why? So for the first, mutability makes it hard to reason about the code. So the more mutation points you have, the harder it is to understand what is going on. So especially if mutation points duplicate, so you have two variables that are in some way redundant, and if one of them changes, you need to change another one. It is getting very hard to reason about this kind of code. Then it requires proper synchronization. So it is especially about multi-threaded programs. And I would like to show it to you in a simple example. So here is a code where I start in 1,000 threads, a simple program that bumps a number. So the question is, what should be the result? And the truth is that it is very unlikely that the result will be 1,000 due to the critical section that is happening here due to the conflicts when we save the code. So it might be 973, 984, etc., etc. Just using coroutines does not help too much. Even if we use coroutines, we require proper synchronization. There are less threads in this case that can have conflicts, but in the end, the result should be more or less the same. So in those cases, we need to think about synchronization when we deal with mutability, and it is often just hard. So here is an example of synchronization that can be done using synchronized block, but wrapping it everywhere is just complicated. Then the more mutation points, the more tests we need to cover. So if you have an object like this one, this is a bank account. When you use functions like deposit and withdraw, you not only need to test for the arguments that you use, but also for all the internal state that you have. The more state you have, the more tests for each function you need to provide, because some combination of those tests can be hard. And those who truly care about proper testing, like we do in Allegro, know that every mutation point is in some way a pain. Then when state mutates, other classes often needs to be notified, and this I would like to show in this small quiz that I often give on my workshop. So it seems to be something very basic, but it is very often that even senior developers make mistake in here. So if I set 10 to A, A to B, change A and ask for a B, so the answer is 10 because we use a value. So mutation point is in here. But when we have an object that is mutable and we set a reference to this object in another variable, we change internal of this object, then the answer is very different. Very similar if we use lists, and this change is often even less obvious for many developers. So here I have var list and I modify it, and so when I ask for the list 2, I start here a value. So again, I have an old list, but if I use a new list, then here is a new list in the mutable 2. It is especially tricky because this notation on the left could be done using plus equality as well. So it is nearly not distinguishable from the other one, and yet the behavior is very much different. So a more, I guess, obvious example is, imagine that you have a list of elements, and this list is sorted. So you have a sorted list of elements, and then you get one of those elements, and apparently the ID of this element that was used as a sorting key is mutable, so you can just change it to something else. And if you do that without informing a list about it, then you get a problem because element is at incorrect position. And if you ask for this list, if it contains the element, it will search it in an incorrect position, and it is not going to find it. So it can tell you that it does not contain this element, even though it does. So it's one of the common problems. In a more practical example, it is that if you, for instance, have an adapter that represents a list of elements, and you change one of those elements, you need to inform an adapter. So it is a constant problem of updating outer states about the change in some child, and that can reveal itself in many different forms in many different problems. Okay, so how can we find with all that? Kotlin has support for the immutability. The three most important parts of this support is the distinction between val and var. It needs to be understood that val is a read-only element, so it means it does not support setting it. What is some kind of a consensus? I say it is not allowing setting and that it is read-only because it is not necessarily immutable for at least two different reasons. So first of all, it can store something that is mutable, and second of all, it can be defined by a getter. So in here, full name is val, but yet if you ask 2 times for its value, it might give you a different value because it's defined by a getter, and the other values might change. What is more, val can be open and can be overridden by var. So I'm saying it's kind of a consensus to let you know that just because something is val does not necessarily mean that it will never change, although it does not support changing. And of course, we prefer true constant values, but this consensus is also very important for us because it gives us encapsulation, it gives us a power to change vals in the future. More about it I described in the book. The same story with read-only and mutable collections, and another great decision of Kotlin to make a distinction. And the design is very similar to val and var, as read-only collections are not necessarily immutable. Actually, under the hood, most often they are mutable collections. They are only hidden behind interfaces that allow only reading elements, so read-only interfaces. So you can see that those read-only interfaces on the left side, they are implemented by mutable collections, and the actual objects that are used on each platform are generally mutable. So what does that mean? Thanks to that, we have really nice capabilities. For instance, if you have a mutable object, it is important to remember that we should not return a mutable object, should not leak a mutable object, because someone on the other side might just get it and modify it. And then if you again ask for this object, it will have different data. So someone got a reference, modified this object, and then and this way modified the internals of user repository, even though it should not be possible. So if you leak the mutation points, like mutable map in this case, then you are exposing it for a mutation from outside. So what Java did was making a copy in here. In Java, in Kotlin, we would make 2 mutable lists again, but it is additional cost and it is not really needed. What we should do in Kotlin is to use a map interface. The same with a list, the same with set. We can hide multiple set into a read-only set. We can hide multiple list into read-only list, which is a very popular practice and a very common way to hide mutability. But of course, or if we can also make this var and map, but this is a different story, and as some of you know, less efficient option. So as you can guess, this trick only works if it is respected by the other side. So if the other side is not trying to hack it by upcasting object into mutable list, into mutable map, etc., and modifying it. So this is something that should be absolutely unacceptable, as this is breaking the contract of this object. When we explicitly limit the number of methods that is visible on the return type, we do that so that the user should not use those other methods. And if somebody truly wants to do that, there are legal way to do it. This particular way of dealing with that is, as I said, incorrect. And to understand why it's incorrect, we need to understand that, you might check how does it work right now, but you need to understand it is not going to be it's not necessarily going to be consistent. So, for instance, this particular code will modify the collection on Kotlin JS, Kotlin compared to JavaScript, as array is used there from list of. In Kotlin JVM, on the other hand, it will throw unsupported operation exception. But I don't know. It's very likely that Kotlin team will introduce persistent collections and return them from behind the list of, and then this code will not accept this check at all. So when you do things like that, you have absolutely no idea how it's going to behave in the future. And the legal way to do that is to use a method like mutable list that makes a copy that is mutable. I would like to remind you that you can ask questions, so I will check them from time to time, and on the end I will also answer them all. Finally, the last important tool that we use in Kotlin to support immutability is to use val over var, and it is especially important when we define data objects. So we strongly prefer read-only objects over mutable objects for many reasons. Some of them we already described. Also, you need to understand that if you use a mutable object as a building block of other object, then this other object has mutability inside, so you cannot go back. And in general, it is very, very good to construct objects from immutable objects. And so mutable objects are much more universal and should be preferred. To show you another problem with mutable objects is that they cannot be used as an element in set. Should not be used as elements in set. They should not be used as keys in map. For this reason, that all those collections depend on the hash set. So hash set is in this case calculated based on name and surname. And so if you put an element into a set, then you modify it, then its hash set has changed. So it is in incorrect bucket. So if you ask for it, you will find it. But if you check if this set contains this element, it will tell you, no, it does not. So how so? It's like we are just looking in a correct basket, so it should be obvious that it cannot be found. So in general, we prefer, I hope that I convinced you that we strongly prefer immutable objects when we operate. But objects needs to change. For instance, if you have a user, the user might change his or her surname. And so for immutable objects, we we started making a methods like with surname. So we, for instance, take an object from database, then we make a copy with different surname, and then we update it to database, or in any other way operate on this new object. So these methods work perfectly fine, but it's, well, if you have many fields, then you have many methods, it's lots of boilerplate code. So instead, Kotlin creators introduced a great method, one of the most useful method in data classes, that is copy. So if you use copy, you have exactly the same result. So you make a copy of an element where you can change something. So if you make a copy without any differences, you just have a shallow copy of this object, but you can change whatever you want. So it's like you have a possibility to change everything, and the default values are the values that were before. So this is the last piece of support for immutable development. And I think we should encourage it a lot and use it. We should also understand that there are different kind of mutation points, and they all have their pros and cons. I mentioned the difference between mutable list and mutable property. So here we have a mutable list and mutable property with a read-only list. They both can be modified in many ways. One of them we modify by modifying an object, another one by modifying a variable. And in both cases, we can use this plus equality sign. So what are the pros and cons of both of them? So it is, I guess, well known that a mutable list is generally faster, as we do not need to create a copy every time. But the difference is not huge. So I'm not making my decision too often based on that. I checked it out and saw that the difference is rarely significant. It's rather some percent, not X something percent. On the other hand, an immutable list can be observed. So, for instance, we can track the changes. We can define a getter and setter. We can use observable to see how it changes over time. So they both have their advantages. I generally prefer mutable lists for local scope, and I think I generally prefer the read-only lists for I would say class scope, so for properties. But it is not a strong preference, so I do not discriminate against any of those choices. I just want to mention that what we should never do is use them both. So var mutable list is something that should never happen. It's like unnecessary mutation points in two places, and we never know which one is actually used. And actually also plus equality sign is illegal because of the ambiguity. Okay, so summarizing this long part, we prefer val over var, immutable over mutable. If we can have val that is truly constant, is generally, of course, better because less to think about, less to reason about. We use copy to make objects immutable, to modify objects that are immutable. We design our mutation point wisely, and we try to limit them, and we try to not expose mutable objects. One more element I would like to add in this section is that you should also think about the scope. So the more elements are visible in some particular scope, the more a reader needs to think about. So it is harder for him or her to reason about the program. That is why we limit scope, we make things less visible in many different ways. And to show you the difference, I wanted to show you this exercise and this problem that is a solution for one of my problems in Kotlin Coroutines workshop, where I asked to make a Fibonacci prime number generator. So what you can see in here is an infinite sequence starting from 2 and next numbers ad infinitum. And the algorithm is simple. We always first the first element. This is a prime number. Then from the rest of elements, we drop the first one, and then we filter out all the elements that are divisible by this prime number. So this solution works perfectly fine. You can check it out. But apparently, in nearly every edition of this workshop, there is a person who tries to leave this prime variable outside, and I would like to let you know that this change does not really make any sense. It used to make sense long time ago. Right now, these kind of changes are introduced by compiler anyway, and compiler generally knows better how to optimize these kind of changes. But also in this particular case, you can see that our code does not work well anymore. So right now it prints like next numbers. And here you can stop this video and ask yourself why. And I will just give you the answer. So if you consider the fact that in Kotlin we are dealing with capturing, then you will see that, and that filter is applied lazily because this is an infinite sequence. Then you will see that since we moved this prime outside, now in all the filters we add, we are referencing to the same prime number, to the same variable. And in every change, we add another filter that filters out the same variable. So let's say we are in the element 6. We are filtering out 5 and 5 and 5 and 5, etc., etc. So it does not improve, does not work correctly, because instead of using value, and we are referencing the variable that mutates over time. Okay, so this is about this problem. Switching to the next section, or maybe next type of problems we would like to avoid, is let's talk about typing. And especially I am interested, I would like to explain the problems with typing on the connection between Java and Kotlin. As you know, Java does not support a proper nullability safety mechanisms. So when we interoperate between Kotlin and Java, we try to infer what is the nullability of this type. And when this type is annotated as either nullable or not, we trust it. But if it is not, well, then we have a problem. To a certain degree, we JetBrains wanted to avoid it by supporting as many annotations as possible, and encouraging library creators, Java library creators, to use those annotations. So it was one of the biggest changes in Android when they started supporting Kotlin. But still, many things are not annotated as either nullable or not null. And in such a case, we are dealing with a special element that is not present in Kotlin in any other situation. That is called a platform type. So platform type is a type that is not yet decided. It can still decide if it is nullable or not null. And I would like you to think about the difference between those two code snippets. The only difference is that here I set the type and here I don't. And in both cases, if we are wrong and value is null, then we will have some null pointer exception, because we get something from Java and we use it unsafely. Okay, but in the first case, we have null pointer exception from middle of an expression without any explanation. I guarantee to you, if there are many things in there, it will just tell you, hey, null pointer exception in this line. No explanation why, from where, how, nothing. On the other hand, if you set the type, you will have a very concrete explanation that the null came from get value, and you tried to cast it to string, and it cannot be because it is null. So I guarantee to you, much easier to find it and fix it. So the lesson here is to eliminate platform types as soon as possible. And then maybe more a bit funnier lesson, not for a person who did that for the first time, but maybe for you, is when you infer a platform type into something that is open, for instance, an interface method. Notice that the type of this get username is a platform type, so it hasn't yet decided if it is nullable or not. So someone on the definition declaration side might decide it is nullable and return null in a fully correct way. And someone else, or maybe the same person on the use side, might decide it is not nullable. And this way we return null, we produce null in Kotlin, we consume it in Kotlin, and we have runtime null pointer exception. And surely there is a warning that tries to protect us against it, and that an inferred platform type should not be present in an open element. But I would like you to respect it, and you know why it's so, and why you should not do that. Okay, so this is one problem with typing. Another common problem with typing is that type inference is exact. So if you make a class animal, and if you have a class zebra that is a child of animal, if you set a variable to a zebra and then try to change it to an animal, then you have type mismatch. Why? Because the inferred type of animal is a zebra. So if you want to fix it, you need to set the inferred type of animal to animal. And clearly this problem most often happens when we have some sealed classes with some options, and one option is the default one, and a different option we want to set in a different situation. But nevertheless, this problem, this situation occurs in many different situations. But this particular one is very easy to fix it. We just know, okay, so I need to set type and that's it. But sometimes we have situations where we cannot fix it as easily. And I would like to tell you a story. Imagine that you got a car factory where you produce cars. Though there is one particular car that in your government, in your country is generally produced. And so you decided that, hey, if this is a default option, why not making it a default value for this function? And then you think, hey, why setting this type? Let's just omit it. It's the same anyway. And soon after that, someone decides that the default car type can be omitted as well, inferred as well. And congratulations, now you can only produce one type of cars, and your country is full of that. This story happened already, and I don't want it to happen again. And the lesson is here to not expose inferred types, especially when you write some library and you, or maybe internal library, or maybe just some class that is used from different parts of your project. If you define some public contract, I think it should be a standard practice to specify types for public functions, because trying to figure out what is the type of each function is truly annoying and frustrating. And also, I would like to add in here that Kotlin 1.4 introduced a strict mode that, among other features, requires that. And so you might consider turning it on if you are a library creator, or if you want to be a library creator. Okay, so let's talk about the third and last section. Let's talk about expectations. And expectations are part of how we communicate our intentions in code for other developers, and also for ourselves in the futures. And in the simplest way, when we have some strong expectations on arguments and state, we specify them in Kotlin using functions require, check, and in terms of unit tests, assert. So require is a function that checks arguments. So if you check using a require block, if this requirement is not fulfilled, it will throw illegal argument exception. Require also supports require not null, that checks that something is not null, and both of them also support smart casting. So if you check require something is not null, or require something is of some type, then it will be smart casted to this type. In the require block, you can also specify a message lazily using this lambda expression. So thanks to that, it will be calculated only if needed, not always. Check is checking for it is checking our state, so it throws illegal state exception. So a typical case is when we speak, we need to check if something is initialized. When we want to get info, we check if token is set. When we will ask for a next element, we check if some collection is open. So again, strong expectations. We throw exceptions if something is not fulfilled. This is offensive programming. We'll talk about it more in a moment. We also have assert block that is a bit different. It throws assertion error. And the point with assert is that it is primarily for unit tests, and you probably know it from unit tests, but you can also provide assert block in the code itself. Why? It is not going to be used in production. It is not going to be used by default. To use it, you either need to run your code in unit tests or other tests, or you need to use a special JVM option. But assertion, we add assertion if we want to specify that something should be expected at this point. So it's like taking our unit tests, taking our checks closer to our functions. This is not a common practice in JVM, but it is a very common practice, for instance, in Python, and this is where I took it from. And I generally noticed that it also works quite well in our JVM world, as it is giving more explicitity of what we require on our code, and it makes our code better, as this is going to be tested on all the unit tests, no matter what happens. I mean, assuming that code got there. Okay, again, require block, universal way to specify expectation argument, check to specify expectations on state, assert to check if something is true primarily for unit tests, and we also have Elvis operator with return and throw. And here is a function that uses them all, I believe, quite properly. So this is a pop function that pops a number of elements. It requires the elements to be smaller than size, so we can pop them all. It requires this collection to be open, and it also asserts that the returned number of element is as we expected. So thanks to the way how we specify it, it is highly visible. It will also not let the code and the incorrect code to be executed. So if this is definitely an incorrect state, we will not let the execution go further with this incorrect data and probably change something that we might not be able to reverse, like modify a database or maybe do something incorrect, but instead it will throw an exception and it's done. So it in many ways protects us, and also it helps us kind of test our code automatically. So this is about the exceptions. We also have a set of standard exceptions that we throw. In general, it's good to know them instead of defining your own exceptions. If you have an exception from a standard library that is already well documented, known, and understood, it's better to use it. Although if you have a case where you need something specific, you can also throw your own exception. So it is all an example of offensive programming that I don't know why, but especially among younger developers, is not having a good grips. It's not very popular, as people often think that defensive way is better, that it never throws an exception. But we need to understand that we have weaker expectations and stronger expectations. So in some cases, it is perfectly fine if we just omit a problem. But you also need to understand the cost of that. If we omit a serious problem, we might never know about it, and we might not be aware that something happens incorrectly. So, for instance, this illegal argument exception is generally considered a good practice because we assume that a developer who is giving an illegal argument is just using our function incorrectly. So, like, we need to inform this developer about it, so that can change this code. And if the code is used incorrectly, it will not going to give us a good result. Offensive programming that is throwing in exceptions and stopping an execution when something is seriously wrong is a different technique. That is a technique for serious expectations that we especially use when something bad might happen if we let it go further. So we talked about expectations. Let's see now a little bit about the second part of this story, about defensive programming. So when exception is not a serious problem, but rather something that might be in some way expected, we generally not throw an exception. So the rule is we do not use exceptions to signalize that something that is standard, that is correct. We use exceptions to signalize that something is incorrect by rule. Sometimes not all the libraries follow that, but this is a general rule pretty well established. And so if a lack of result or incorrect result is possible, instead of throwing an exceptions, we prefer either returning null or returning a failure. There is also an option of returning a default value. So how does that work? So previously we've seen an object throwing a JSON parsing exception. Now we have object read object or null that returns a null if it cannot read an object. You surely know this pattern as it's very popular in the standard library. And I'm happy to see that it started getting more and more popular in non-standard libraries, so in other libraries as well, and in our code as well. So null can be a standard way to signalize, that we couldn't produce a proper result, and yet it is fine. It's just like a pointer to signalize, okay, so for some reason it couldn't be produced. So now it's up to you to decide what to do with this fact. So if we do not need to provide anything more specific, null is perfectly fine. But if we need to provide more concrete problem, then a better way is to use a result. So some might say that we should use either instead of results. So either is a part of arrow that does the same, that has the same function and the same idea stands behind it. So instead of throwing an exception, we return something that is either an exception or a success, and the user is forced. The developer who is using this function is forced to properly at least consider and handle both situations. So using those functions and giving, for instance, a default value for each of those options is relatively easy. So in the second case, it takes a bit more code, but it is still not very hard. And if someone makes an extension function on result, then it can be as simple as the first one. So you can make any extension function you want. From your perspective as a designer of an API, as this is where I assume your concerns, you have the most decision, is to the good practice is to give options. That just like list gives option, and you can get element, you can get or null element, or you can get or default element. And similarly, when you design your own API, you might give an options. So, hey, find something or null, or maybe even other option, like in here a default. But I think in most options, or in most cases of our own, we do not need this default option. Someone can always give a default using this operator, as simple as that. Yeah. Okay. So to distinguish those things, when we think about handling nullability, we cannot just ignore nulls. We can use a safe call. That is, in most cases, the best option. It's like, hey, do nothing if this is null, but you need to remember about the costs. So if this is important that it is called, and you expect it to be called, then this is incorrect, because it might not be called, and you might be wondering why, and you might never be informed that this variable is null, and that is why. So if you expect that this variable might or might not be null, it's perfectly fine to use safe call. But if you assume that, hey, this variable at this point will not be null and this will be printed, it's better to use some more aggressive option. And in this case, smart casting works the same as safe call, and not null assertion is a more aggressive option. Though I'm not saying it's the best option, you can also use other functions like require not null and check not null that give you better explanation. And in most cases, I encourage you to do that. You can also use LBS operator and, for instance, return or do something else to handle that a bit better. So yeah, this is an example of require not null and check not null to give a stronger expectations. Okay, and I hope that you have more or less clear picture of this battle between offensive and defensive programming. They both should be used, and they both have their uses, and they are both well supported by Kotlin. So defensive programming, we can support it well using things like safe call or LBS operator with return. We can easily provide default values, and it is good if we as API developers let user decide how to handle it using functions like with, for instance, get or null suffix or with that return result. Offensive programming is throwing in exceptions. Those exceptions, it's best if those exceptions are well explanatory. So if it's required not null or check not null, and if they have some text that explains that, we use that generally when we have strong requirement, and we do not want to let user go any further in case of this not being correct. And the last thing I would like to touch is when you read a file, I still sometimes see people doing something like reading line using, I think it might be an outdated API. Oh yeah, line sequence. It's a buffered reader. Yes. So doing something like that, old Java habits. But you probably know that it's not correct, as this file needs to be closed when it's done. So something like that would be a little bit better. But if you read something more about it, you know that it's not safe neither, because an error might be thrown from this close function. So it's getting quite complicated. So instead, we use a function use from the standard library. For everything that is closable, we can just wrap it, call a use on that, and thanks to that, it will surely be closed once we exit this scope. But in terms of reader, this can be reading file. This can be way further improved. So this use function can provide a reader as a parameter. So we can just call it on a reader. And in terms of files, you can just read file using function use lines that basically does practically exactly the same. And here I want to add that we use function use lines instead of read lines, I think. Read lines, if I remember it well, returns a list that might be big. If file is big, what is incorrect? Instead, we use lines that give us a sequence that is reading elements line by line and never store more than one element. And this can be further improved. So this return can be lifted as use lines return the result. So it can look like that. And I hope that this way of reading a file and summing the number of characters is satisfactory to you. And the last word, literally last word about best practices is that we cannot talk about safety without tests, especially unit tests in our world, but also integration tests. It seems that they are getting more and more popular. Having tester is not enough. We should test our own code. We should test components, and we should think about testing stuff, because it is also important that we understand testing and what do we want to test. We in Allegro care about it a lot. This part is absolutely non-Kotlin specific and basic, but nevertheless important, and such items are in the book as well. So yes, we truly care about testing in Allegro. It was one of the reasons why I decided to join this place. Another one was that it's a place of development and place of best practices. And now, after nearly a year in here, I can confirm that it was a very good decision, and I can recommend it to everyone who wants to become a better developer. And the book, Effective Kotlin, those are the items we covered. The presentation, together with other presentations, will be placed in the website I maintain and develop, that is KT Academy website. On the courses there, you can find some courses. If you are a workshop attendee, you can find all the materials from the workshop and recordings. If you are not, you can find some challenges like Advent of Kotlin challenges or preparation guide for workshop. That is a good introduction for beginners. And there is also this effective Kotlin materials, with all the materials that I recorded about effective Kotlin itself, and soon I will also share the recording. And also we work on more free courses there, so I can tell you soon you will be able to find more materials. Okay, and that is everything from my side. Thank you. I hope that you learned something today and that it will help you improve your Kotlin. Have a nice evening and have a nice Kotlin.
Thanks a lot, Marcin. So let's give like 1 minute to ask you any questions. So far, there are none. So let me just shout it out now. And in the meantime, I would like to really thank you, Marcin, for your support here. Just to bootstrap this new Kotlin user group, I got some really nice hints how to promote it, and even just your participation today makes a great difference. So thanks a lot, and hoping to host you maybe one day in person, not like now, sandbox with a camera.
I'm happy that you're doing that. I know it's a lot of work, and I think it's an important work that we have more presentations and more learning in Poland in here. And I know I believe it's harder to do that online due to the other meetings, but nevertheless, I think it's important work.
Yeah, thanks. So it's a bit hard because I just had to look up some broadcasting tool rather than just finding a room and just having a meeting. So it adds some overhead, but after all, it's doable. So yeah. Okay. So far there are no questions. Keep in mind that you can ask them under the video after we end the broadcast, and also after we publish the video with Marcin's presentation on YouTube. So hopefully Marcin will also answer these questions. Okay, so thanks a lot. Or maybe we'll just take a 5-minute break before I will start as promised. So thanks a lot and see you in 5. Oh, okay, I have no questions, just want to thanks, said Jalma. That's cool. Thanks a lot for joining us.